Hello, this is question number 10 from assignment 6. The question is to design an URL shortener. So in the database, the URLs which are stored have an associated integer ID with them. Okay, so what we do in this solution is that we take that integer ID which represents the URL and we convert it into short 6-character URL. So this 6-character URL can have one of the following, or can be one of the following. It can have any letters from A to Z lowercase. It can have any letters from A to Z capital case, and it can have any number from 0 to 9. So this A to Z will be 26 characters, this A to Z will be 26 characters, 0 to 9 10 characters. 26 plus 26 plus 10 is 62 possible characters. So now what we do is we take that unique ID which is in the database, the decimal number, and we convert it into base 62 number. So for example, if the ID in the database is 150, we take that 150 and convert it to base 62. First we division will give this. Okay, then 150 mod of 62 will give remainder, that is 26. So 220. So further if we divide, it is 0 and 2. So this is the converted base 64 number. So now I got this. Okay, now I take a string A, B, C to set, and capital A to set, and capital and 0 to 9. So I take the string and mark its index. This is 0, this is 25, this is 26, that is 51, 52 and 61. So 26 characters, 26 characters and 10 characters. Okay, now I take this and I see what is there in position 2. Position 2 is C, and next what is there in position 26, that is A. So this is the shortened URL. CA is the shortened URL of ID 150. Okay, now to get back, so from this to get back the ID, what we do is we see its position 2, see its position here 26. Okay, and then 26 into 62 to the power of 0, this is 2 into 62 to the power of 1, something similar to conversion of base 2 to base 10. So this will give 124 plus 26, that is 150. So we got the number back. This is idea, this is algorithm for this program. So now we'll see the program. So here I have defined a function. It takes an ID. As I said, I am taking a string here, then short URL variable to store the short URL. Then while ID is greater than 0, then first I do mod plus short URL, then division, something similar to what we did here. Okay, next I to get the ID back, first I reset ID value to 0, then I loop through the shortened URL, okay, and take each character and store its ASCII value in this variable. Okay, now I'll see if this C is present in this or in this or in this. I'll see if it is a small letter, capital letter or a number. So if value of I, that is the ASCII value of C, is greater than the ASCII value of A and less than ASCII value of Z, what does it mean? It is checking if it is present in between this. In that case, ID is equal to ID into 62 plus ASCII value of C minus ASCII value of A. Okay, so if we take 150 as example, we got CA, right? So how do we get CA? Okay, let me walk you through this. Okay, now when ID is greater than 0, short URL is map of ID 150 by 150 mod 62, that is 26. So map of 26 is A, capital A. So we got capital A in short URL. Okay. Next. Now ID will be math dot floor of ID by 62. ID is 150. 150 by 62 is 2. So ID is 2. Okay. So next again ID is greater than 0. So map of 2 by 62, that is 2 mod of 62 is 0 plus A. Okay, one second. Oh sorry, 2 mod 62 is 2. So map of 2 will be C. So short URL was A in the beginning. Then now we got A plus C. So we got CA. Okay, for the next iteration ID is now 2, right? 2 by 62, that will be 0, and it comes out of the while loop. We got CA. Okay, next now we take this A, loop through it, and first we find ASCII value of C. Yes. Okay, so C's ASCII value is, small c's ASCII value is 99. So 97 is small a, 98 is small b, 99 is small c. Okay. So value I will be 99. Okay. So is 99 greater than or equal to 99 and less than set? Yes. So it comes inside this. ID is equal to ID into 62. ID is 0. Okay. 0 into 62 plus 99 minus 97. ASCII value of A. So that is 2. So now ID will have 2. Okay. Next. Again. For the next character A, it will come to this else if condition. Value of I for character A will be 65. 65 is greater than or equal to ASCII value of A, and it's less than ASCII value of set. So it comes inside this. So ID was 2, right? So 2 into 62 plus value of I, that is 65, minus 65. Okay, plus 26. Why 26? We are trying to find the position here. Why we are subtracting the ASCII value is that, see, ASCII value is in the order, and here also it is in the order. So by subtracting the ASCII value, we can find the position of that character. So 99 minus 97 is 2. So 2 is the position of C here. So that is the idea. So to find the position of next A, we have to add plus 26 here because capital A is found after first 25 characters. Okay. So this is 0. 62 into 2 is 124. 124 plus 26 is 150. So ID will now have 150, which is the ID which was first sent. So we got back the ID. That is the idea. The time complexity of this function is O of n, and space complexity is O of 1. So O of n, because if where n is the length of the ID. So we loop here once, and then this is to reverse. So here also we loop through this character. So approximately time complexity will be in the range of O of order of n. Thank you.